Hello and welcome, Algebra 1 students, to our video on the laws of exponents. This is part 1. We're going to cover all of the multiplying rules and positive and negative exponents in this video. So let's start now. Start with remembering how expressions with exponents look. So when we're talking about an expression with exponents, we're talking about one that is called a power. A power is the product of multiplying a value by itself. A power is represented with a base and an exponent, and that's what you're looking at here. This entire expression is a power, and that's x to the nth power is how we would pronounce that, x to the nth power. Well, we have different types of exponents. We're going to start with zero and negative exponents. Let's start with zero exponents. Any non-zero number, I should clarify, any non-zero number to the zero power, so a to the zero power will always equal 1. And it does not matter if it's 5 to the zero power, that equals 1, or if it's 5 million to the zero power, that also equals 1. And that is a rule that will always be followed unless we're talking about 0, and that's why the definition is non-zero number a. 0 to the zero power is what we call undefined. It's kind of like dividing by 0. I ran out of space for the rest of my word, undefined. For negative exponents, for every non-zero number a and integer n, a to the negative n is 1 over a to the n. Negative exponents are reciprocal makers. So negative exponents are what I like to call reciprocal makers. Reciprocal is where you flip the number over. So if I was talking about the number 2, the reciprocal of 2 would be 1/2. And in fact, if I raise 2 to the negative 1 power, I get 1/2. 1 over 2 to the positive 1. So negative exponents, editing jump. Negative exponents give you tiny numbers, not negative numbers. So when we find, starting with up here, 4 to the negative 3 power, my answer is not negative. My answer, using the rule we learned, is 1 over 4 to the positive 3 power, which is 1/64. Picture a pizza cut into 64 slices. One piece is 1/64. So again, negative exponents give me tiny numbers, not negative numbers. Negative 5 to the 0 power. Well, it doesn't matter what the base is, that's 1. 3 to the negative 2, so that's 1 over 3 to the positive 2, or 1/9. 6 to the negative 1, 1 over 6 to the positive 1, which is just 1/6. Now, there's a negative base, which is a different circumstance here from up here, then my answer will be negative when I have an odd power, but that has nothing to do with the negative exponent. So this is the same thing as saying 1 over negative 4, the quantity raised to the positive third power, which is 1 over negative 64, which we're going to write as negative 1/64. Now, when we add in variables in our expressions, we have to recognize that each of the different things multiplied in the expression has its own exponent, unless you see parentheses. So the 5 has an invisible exponent of 1, the a has a visible exponent of 3, and the b has a visible exponent of negative 2. Take the expression and put it on a fraction bar. Anything with a negative exponent switches to the other part of the fraction. So that means this is 5a to the third power, and only the a is being raised to the third power, over b to the positive 2 power. And that is simplified. I can also say in that circumstance that b cannot be equal to 0, because I can't have a 0 in the denominator, but that's just an additional point to make. So notice again, the 5 is still a 5. I can't flip it to the bottom of the fraction because that's not a 5 anymore, it's a 1/5. The a cubed stays up top, and then the b to the negative 2 comes down to become b to the positive 2. This is a little different. Now our negative exponent's in the denominator. We're going to move it upstairs. So when we do that, we end up with x to the positive 8th power. Because we learned 1 over a to the negative n, a to the negative n is 1 over a to the positive n. Well, this goes the other direction as well. If I have my negative exponent in the denominator, I move it upstairs to the numerator to give our answer, And it's no longer a fraction, even though we know there's an invisible 1 under there. That's just x to the 8th. You wouldn't write x to the 8th over 1. And this last expression is m to the negative 5th over n to the negative 4. The quickest way to fix that is to notice that both of them have negative exponents. They're going to switch places. So we're going to put n to the positive 4 up top and m to the positive 5 down on the bottom. Again, that's what negative exponents do. They make reciprocals. So work with those negative exponents on IXL or Khan Academy, and you'll get the hang of it. You'll start having that intuition to recognize what to do with them. Now let's talk about multiplying two powers. When you multiply two powers that have the same base, you keep the base and you add the exponents. The rule is written out in mathematics usually as a to the m plus a to the n equals a to the m plus n. And a can't equal 0 because we don't raise 0 to powers, and m and n are both integers. So for this first one, we're going to keep the base. So you keep the 9, you add the exponents. 5 plus 8 is 13, and that's 9 to the 13th power. Now for my folks who are pausing and writing it out, that answer comes out to be 2,541,865,828,000. Oh boy. All right, how about the next one? Keep the base, add the exponents. So negative 4 plus 6 plus invisible 1. Make sure you recognize there's invisible 1 there. Negative 4 plus 6 is 2, plus 1 is 3. 4 to the 3rd power equals 64. And you will find that you know a lot of the small powers of small integers already because you use them in class all the time. All right, for this next one, we're going to have b to the 7th times b to the negative 4. So keep the base and add the exponents together, and we get b to the positive 3. And then finally, keep the base, add the exponents, z to the negative 7 plus 2, which is z to the negative 5, which we then have to rewrite. It's a rule that we have in algebra that we cannot leave a negative exponent in an answer. So make sure you always rewrite with positive exponents at the end of the problem. Just a very brief addendum. I never explained why this works up here. So let's real quick talk about why this works right here. Let's do it with this one. 9 to the 5th power would be 1, 2, 3, 4, 5 9s written out, and 9 to the 8th power would be 1, 2, 3, 4, 5, 6, 7, 8. No, not 9 9s. Come on, 8th power, LeCompte. Would be 8 9s written out. Now count them all the way up. Let me stick the little dots in between them so you can see it. How many are there? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's why we're allowed to do this. And you don't want to write this out. That's why we learned this rule right here. Okay, now we're going to add into it that now we're going to have monomials. I always thought of the word monomial like it's a little monster, and I found this picture and just thought it was really cute. I think that's Class Dojo, but I don't care. It was just so cute. I like to think of those as my little monomials, like minions. But a monomial is not an animal. It's a number, a variable, or a product of numbers and variables. So this is a monomial. This is a monomial. So is this. So is this. So is this. So is this. Each of these different things is a monomial. Notice that none of them have addition or subtraction in them. Negative signs here and there, but no addition or subtraction. When you multiply monomials, you're going to look at what sort of the like terms are that go together. Well, when I multiply this, remember that the order that I multiply in does not matter. Commutative property does apply, and I can say that this is 5 times 4 first, and then x times x squared, and then y cubed times y. Now, I wrote it out now, but over time, you're not going to need to write that out. 5 times 4, that's 20. X times x squared, remember your invisible 1, that's x, to add the exponents, keep the base, add the exponents, to the 3rd, so x to the 3rd, and then y to the 6th. Same idea on this one. And so this time, instead of writing out that product, I'm just going to go ahead and do the multiplication. 7 times negative 4 is negative 28. M times m to the 5th is m to the 6th. Don't forget about your invisible 1 exponent. On this one, a little bit more work to do. 2/3 times 9, or 2/3 of 9, is going to come out to be 6. So I have 6. A to the 7 plus negative 3 is a to the 4th. And then b to the negative 3 plus invisible 1, which is negative 2. like we did on the previous screen, the 6 and the a to the 4th stay in the numerator, this invisible fraction, even though we don't see it, it's there, and drop down the b to make it a positive exponent. Sometimes I like to think of an exponent as multiplying repeatedly. So this means multiply m times m times m times m times m times m. That's what that actually means, m to the 6th, right? Well, b to the negative 2, think about this as dividing by b 2 times, which means I'd put b times b in the denominator. I'm dividing by it 2 times here, b and b, and that's b squared. So that's one way to interpret those negative exponents to help you remember what they are doing. 2 more concepts and we'll be done with your video. Power of a power. To raise a power to a power, keep the base and multiply the exponents. Now on this one I want to take a second for the first problem and I want to make sure you understand why this is happening. Now let's look at the way it's stated up here first. A to the m raised to the n power is a to the m times n power, where a is not equal to 0 and m and n are integers. So that's what we see here. Now what does to the 4th power literally mean? It means d to the 5th times d to the 5th times d to the 5th times d to the 5th. Now if I used my product of powers rule, which is same base, keep it, and add the exponents, I would add 5, 5, 5, and 5 for a total of 20. Now go all the way back over to here. What's 5 times 4? Well, it's 20. So what we are learning right here when they say multiply those exponents is not necessarily a rule, it's a shortcut so that we don't have to write workout every time. What's d to the 4th raised to the 5th power? Well, again, keep the base and multiply your exponents. How about d to the negative 5th raised to the 4th power? Keep the base and multiply the exponents. And finally, rewrite no negative exponents in our final expression. Power of a product. I apologize for the blurriness of the rule in the middle there. I don't know how that happened. To raise a product to a power, raise each factor to the power and then multiply. So on this one we have 4y squared, the quantity, so this whole thing in parentheses raised to the 5th power. That means that my exponent is going to be used, that 5 exponent is going to be applied to the 4 and to the y squared. So this is 4 to the 5th times y to the 2 times 5, power of a power multiply, which is 10, and 4 to the 5th power comes out to be 1024. So we should have that expression there. On this one, apply the power of a power first. So I haven't used my w to the negative 2 yet, but I have w to the 21st power to multiply by it. And remember here, now I'm multiplying power times a power. Okay, so we had the power of a power here. Now we've got to multiply these. Keep your base, add your exponents together. Let's stop for a second and think about why that works on that one. Well, if it's w to the 21st power, then it's w times w times w times w written out 21 times. And I'm too lazy to write out all of them. Sorry. And then if it's w to the negative 2, that comes down under the fraction, and that's w times w. Well, if I was to cancel out those 2 w's, I would have a total of 19 of them left, and that's what gives me the w to the 19th power. Our last one is a little bit tougher. Might I suggest at this point in the game pausing it to try it yourself to see if you can get the right answer? And if you did, I want you to jot that down in your notes because that's quite the accomplishment. This is a challenging subject. My husband had a calculus professor in college who used to say that trying to get calculus students as freshmen to understand just the simple algebra laws of exponents was the hardest part of his job. So that right there tells you that this is not an easy concept. We've got to work at it and we've got to make sure it sticks. All right, so at this point, if you've already paused it, here I go writing out the work. 3 to the 4th, first of all, because recognize that that's a power of a power, times n to the 20th. When we multiply our exponents for n to the 5th raised to the 4th. N to the 5th here raised to the 4th. Here we have n squared raised to the third. Power of a power, multiply. Finally, let's multiply out the coefficient. So this is 3 to the 4th is 81. And then n to the 20th times n to the 6th is n to the 26th when I add them together. And I want you to notice that there was nothing for me to multiply by here because the coefficient of the n to the 6th is a 1. So I didn't need to multiply. It was 81 times 1 to get the 81. Practice, practice, practice. This is an important one to make sure you make some time on iExcel or Khan Academy, and it will get easier. See you guys in class.